Now you know we have tabular and we have multidimensional. I know it's harder to listen after you have eaten something, but I need to talk, and so my life is harder right now. We have tabular, we have multidimensional. Tabular is the new kid, young, fast, quick, with a lot of memory. Multidimensional is the old one. And you might have one approach, very religious, that says, I am X velocity, your new engine, and thou shalt have no other engine before of me. And this might be an approach. I know a lot of people that believe that now we have tabular and this is the only approach we can have. Or we can do a different thing and say, okay, now we have two different engines. Which are the strengths of both? Which are the weaknesses of both? And why should I choose one against the other? Which is the best one in which case? So now we are going to analyze pretty quickly several scenarios, trying to understand which model would be the best and why. First of all, here are the slides I had lost. I just didn't remember where they were. When it comes to server size, we have already spoken about this before, but you have to think that RAM is somehow useful for multidimensional and absolutely mandatory for tabular. RAM speed is important, but it's the most important thing you need to care about for tabular. Core speed is very important. This speed is totally useless. Tabular simply doesn't use RAM. And for this reason, the idea is don't use the same server for both. If you already have a server, for sure it will be a server for multidimensional. It will probably not be a server for tabular. If you try to make tabular run on a multidimensional server, you are not going to get the best performance. If you want to go tabular, you need to buy a tabular server. Otherwise, you are not getting the best. And you cannot use the same box for both, not because they cannot live together. They can happily live together, but they have so completely different needs in terms of hardware that there is no server that has all the features of both, or it would cost so much that it is hardly something that we can normally buy. It's pretty important, the part about concurrency. While we know very well how to handle thousands of users on a single server with multidimensional, we don't have a lot of experience in the same scenario for tabular. So before building a solution with 1,000 users running at the same time on a single server and choosing tabular, take your time to think about it, because it might be the case that you will encounter problems that we still have not faced. We don't have experience. We have never tried tabular in a scale-out scenario with a lot of users running currently on the same box. We know that multidimensional can scale well, and we have techniques to do with that. We don't know that about tabular, so take your time and don't simply trust the new kid, because in some scenarios it might fail without you knowing exactly why. Yep?
Have you tried running tabular on virtual machine?
On?
Virtual machine.
Yep, but I have never measured in a clear way the differences between running in virtual machine or running on a physical box. That should be pretty easy, because you just test it and make it run. But in order to be completely fair, you should use not a virtual machine running alone on my notebook, for example, because otherwise there is no real difference between a virtual machine and a physical machine. You should run a virtual machine on a very big server where the core can be switched, because tabular is very sensitive to level 2 cache. If it has a lot of optimization for level 2 cache inside the core, because level 2 cache is tied to the core, so it loads data inside L2 cache, and then he can process it very, very fast without having to share the cache with any other core, with any other CPU. If you run a virtual machine in an environment where there are many virtual machines running, it might be the case that your core is taken from somebody else, and so the level 2 cache is destroyed. And in that case, it might be the case that tabular doesn't perform so well. But I have never tested it in the correct way. the generic word, the generic advice is should perform pretty well. That doesn't mean anything. So it would be much better to test it and to check whether it works or not. So this is the SQL Server appliance I was speaking about this morning. If you want to buy an appliance for SQL Server, they are going to bring you something like that. It's taller than me, and you can try to count the number of disks. There are really a lot of them. And this is the Power Pivot appliance. It's much smaller, but it handles very well huge amount of data, just because it has a lot of memory and 2, 4, 6, 8 disks, which are more than enough for Power Pivot or for Tabular. There is no need to have hundreds of disks, because they can be as low as you want. There are limitations in Tabular, something that you cannot avoid. If you need them, you cannot solve them. Database must fit in memory. You don't have translations. If you rely on translation because you are working for a big company that needs translation in different languages of attributes and data, no way, you don't have them. And so Tabular is not for you. You cannot create sets, and this is not a very big problem, but if you have cubes with rely on sets, you cannot create them. MDX script is not available. If you have an MDX script of several thousand rows, well, the first thing is ask yourself why. I have never seen big MDX scripts which are really useful. They normally means that there are some problems in the cube design, but if you strongly rely on MDX script, then you will have problems in moving on Tabular. And you only have one-to-many relationships. The engine only supports one-to-many relationships. You can, of course, create many-to-many relationships. You can create more complex relationships. You can create using DAX more or less whatever kind of complex data model you want, but it will be harder to do. You need to learn DAX and you need to play and create complex scenarios. So there are limitations and you need to obey them. Distinct count, here Tabular is a clear winner. There is really nothing to say. I have seen scenarios where you have marketing cubes that contain a huge number of distinct count, and just distinct count are a good reason to move to Tabular, because they perform so fast and they are so easy to create that moving a cube containing a lot of distinct counts is you are going pretty for sure to get very good performances and very happy users. In multidimensional, you need a dedicated measure group, partitions, and partition need to be done on the core level. So if you have a server with 8 cores, you are going to create 8 partitions. If you have 17 cores, you create 17 partitions. So you are designing for the hardware, which is not very smart, but it's the only way to make distinct count run at a decent speed in multidimensional, and then order by during processing. This is craziness, but it's there, and we need to handle that. In Tabular, simply write a formula and it's there. And you can do as many distinct counts as you want. They all run at an incredible speed. You don't need any special processing. You don't need partitioning. You have no special measure group. You just simply use it and query it. And everything is pretty easy. Aggregation. How many of you love aggregations? You love aggregation, really?
Yeah.
That would be interesting to understand why. No, the point of aggregation is that a lot of people love aggregation because they make the cube run very fast, but the only reason of being of their aggregation is that because you get better performance due to aggregations. The problem of aggregation is that I have seen so many people creating aggregation with the wizard and then forgetting about them. After a couple of months, after 1 year that you have created aggregation, you need to check them again. You need to do usage-based aggregation. You need to follow aggregation in order to always have the correct set of aggregation for your cube. If you just create and forget, then at a certain point, you are paying a lot of time during processing to create aggregations, which are completely useless because nobody is really using them. In Tabular, aggregation are simply gone. You don't need aggregation. You cannot create aggregation because at the end it came out that it was faster to compute in memory than to search for a suitable aggregation that contains the result. And so they decided to remove all the code that used and checked aggregation and to simply compute everything immediately. So aggregation are gone. You do not need to follow all these complex steps in order to use aggregation in the correct way. You don't need them. Aggregation are gone. Attribute relationships are gone. You don't need to use attribute relationship. You don't need to create natural hierarchies. You have a very, very simple data model, much easier than before. So if you relied on complex aggregation, or if you have a scenario where you cannot find the correct aggregation, again, this is one of the cases where tabular is working very well. For example, one of the scenarios where aggregation are not very useful is whenever you need to do leaf level calculation like currency exchange. If you need to compute something going at the leaf level, then there is no aggregation that can help you. You will need the power of computing at the granularity level of your fact table. And in this scenario, tabular is a clear winner again. Because for tabular, each query is always a leaf level query. There is no concept of aggregation. There is no difference if you want to count the total of sales over 1 year. It's always compute the total over the complete fact table. You don't have a query that runs fast, but if you go down a specific level, it is slower. It will never happen just because aggregations are no longer here. How many of you know what a tool dimension is? Nobody knows it. So you are not missing anything, but you are missing something really interesting in multidimensional. Tool dimensions are related to the fact table, which are useful to make it easier to browse the cube. And they are very easy to create in analysis services multidimensional because they rely on measures current member, which is one of the features you have in DAX, in MDX, and so they are pretty easy to create. So if you have year-to-date, month-to-date, quarter-to-date, running total, several different kind of calculation, you can create a dimension that lets you perform the same computation over all the measures without having to write the code for measure by measure. In DAX, these are a real pain. It's something that is very, very easy to do in MDX. It's very, very hard to do in DAX. So if you have never used, you are not missing anything. But I suggest you to go studying them on multidimensional because there they are really very, very interesting if you want to compute something complex over time. Parent-child hierarchies might be good or not, depend on the way you look at them. In multidimensional, parent-child hierarchies are normally supported, so you can create quite easily parent-child hierarchies, and they work. But they are amazingly slow. So whenever you have a parent-child over a big fact table, you know that you cannot live with this scenario because it will be too slow. And you end up naturalizing them. So you use bits helper, you naturalize your parent-child hierarchy by defining the maximum number of children, maximum number of levels of your hierarchy, and then you use the naturalized version. In this way, you can use aggregation and everything else. In tabular, you can only create naturalized hierarchies. So at the end, there is no difference between them. Because in multidimensional, you have a feature, but it is so slow that nobody uses it. In tabular, you don't have the slow feature. In reality, it's pretty easy to understand why tabular is very fast, because they removed anything that is slow. So only fast things remained in the engine, and now they can say it's very fast, but it's very, very fast. There is only one problem, which is, by the way, right now solved by bits helper, because if you look, I think I have a parent-child hierarchy somewhere. Yep. If you create a parent-child hierarchy in tabular, and you create and you put the amount here, this is the way parent-child are shown by default in multidimensional. And they are not, it's not very sexy, because Annabelle is not something that anybody wants to look at. This is a rugged hierarchy. I would see Annabelle and then Catherine. I don't want to see Catherine as children of Catherine, but this is the way that Power Pivot works with hierarchies. If you want to solve the problem in multidimensional, you have a property which is hide member if, so that you can hide a member if it is equal to its parent. So you remove all this ragged member, all this member, and you get a better hierarchy. You can solve the problem using DAX. So you have this hierarchy. This is a correct parent-child hierarchy, where Annabelle is the mother of Catherine, Harry, and Michael, and the hierarchy is correctly ragged. You can solve this in DAX, but it's pretty complex DAX, so you have to learn DAX before solving the problem, or you can leverage the hide member if feature of the server. Hide member if is available in Tabular. It's there, it works, but for some reason there is no user interface that lets you set this property on a hierarchy. So the feature is there, but you cannot set it. The guys in BitsHelper decided that it was too stupid to live with such a limitation, so they created a user interface that lets you set the property on the server. So hide member if it's not available, you can create using DAX, or you can leverage BitsHelper and work with the new feature of hide member if, which is available on BitsHelper. Unary operators. Unary operators are often used with parent-child hierarchies. They work with any hierarchy, but they are often used with parent-child hierarchies. If you have a unary operator, multidimensional supports them immediately. You don't have to do anything. You just add the unary operator column, and you are up and running. The server will handle all the complexity of that for you. If you want to use unary operators in Tabular, the DAX code that you need to write is really, really complex. So this is a scenario that can be solved, but I wouldn't take this trouble. If I have a parent-child and unary operator, I will just stay in multidimensional because it's a much better modeling experience. You can trust code that works, and you don't have to create every time complex DAX code that might fail or might not be the perfect one. So parent-child with unary operator are one of the scenarios where multidimensional is a clear winner. There is no reason to go there. And if you have custom rollups, which means a unary operator on steroids, you can assign to each node a custom MDX formula that computes the rollup of children in order to compute the total of the parent. This is something that cannot simply done in DAX. You have no way to create a DAX formula that it's data-driven, because custom rollups are not written in MDX, are written in MDX but inside the data. So the engine takes the formula from the data and then computes it on the fly. There is no way to do that in Tabular. So if you have a parent-child, or if you have any hierarchy which uses custom rollup, simply forget about Tabular. It's one of the scenarios where it is far, far better to go in multidimensional. Or you can try Tabular, but you probably aren't going to do anything really interesting. The customer will not be very happy. And then, depending on how much MDX code you have in your data model, you are probably creating in your MDX code measures like ratio to parent, which are very easy to write in multidimensional, because in multidimensional hierarchies are one of the pillars of the language. The language contains a lot of functions like current member, parent, or previous member, next member, to navigate through hierarchies and get the ancestor or the children of a hierarchy. So all the measures that navigate hierarchies in MDX are very, very easy to author. The same measures in Tabular are always a pain, because in Tabular hierarchies are there, but they are not part of the language. So they are just a user interface. They are an easier way to browse information and to show them to the user, but they are not part of the language. You cannot take the children of a hierarchy, you cannot take the parent of a hierarchy. There is no concept of hierarchy and attribute relationship. So it's not a big issue from the user point of view. It can be a big issue from the programmer point of view, because you will end up writing much more complex code in order to solve the problems. If your customer asks you something like ratio to parent, which is very easy in MDX, it's a real pain to do in DAX. It can be done, but it requires some skill and some foresight of what the customer will ask next time. Leaf level calculation, it's completely different if you think of the same solution in DAX and in multidimensional. Scenarios where you need to do leaf level calculation are, for example, weighted aggregation or currency exchange. If you need to do currency exchange on the fly, then you need to apply a different exchange for different currency in different dates, and the only way to do that is go leaf level and compute for each transaction at query time the value of one transaction in the correct amount. Weighted aggregation are, again, something that it might be useful to compute at leaf level because you want to take the aggregate of a value by weighting for some numbers. And this is not a simple aggregation, but need to aggregate a multiplication divided by the simple aggregation. They are very easy to compute in DAX, and they are incredibly fast to compute in DAX. Even if currency exchange is not very easy and not very intuitive, the formulas that you need to write need to be studied in the correct way, because they really depend on the distribution of values and on the kind of formulas that you want to write. So it's not very easy to write the correct DAX code, but once you have it, it is much, much faster than MDX. So you can use currency exchange and your customer will be happy. In multidimensional currency exchange, it's always a pain. And moreover, all these calculations don't require changes in the data model. Just to give you an idea of the differences between multidimensional and tabular when it comes, for example, like weighted aggregation, think that you want to compute the mean price. The mean price, which is the weighted mean price, I want to compute the weighted mean price by taking the average of the price by averaging by the quantity. So if I have sold 100 products at $100 and one product at $1, then the average of the two, it's not 50, but it's more near to 100 because the quantity for 100 is much higher. And this formula will work fine. It says price multiplied by quantity divided order quantity. It's the price weighted by the quantity. The first time I had to solve this problem in tabular, I solved it this way. That is, I created a column containing the price multiplied by quantity. It was a calculated column because I wanted to use sum to compute it very quickly. And then I created my formula. For a lot of reasons, I had to send the database to Seattle to the development team because they wanted to look at the code and they wanted to improve the performance of the database. And when a guy from the development team looked at that formula, called me and says, Alberto, why did you do something that stupid? I said, there's nothing really stupid here. Let me understand what's so stupid here. If you count the number of distinct values of price, it can be 100, 1,000. If you count the number of distinct values of quantity, it's still a big number, but not so a big number. If you count the number of distinct values of the multiplication of price multiplied by quantity, you normally get 2 or 3 orders of magnitude more than the number of distinct values of the two, because by multiplying you are increasing the number of distinct values. And it turned out that on my fact table, this column, this simple column, was using something like 9 gigabytes of RAM just for one column, because it had a huge amount of distinct values. And of course, scanning it was very slow. Very slow means some seconds in order to get the answer. It was much faster to compute it on the fly. Just store the price, store the quantity, and then scan completely the table, computing the multiplication on the fly. It turned out to save, I don't remember. Yes, by using this formula, this computes for each row of the fact table the multiplication. So I don't store the column, I just store the two sources. I compute using it this way, and then I divide. I went from 13 seconds to compute the first formula to, I think, a couple of seconds using this expression, and 9 gigabytes of RAM saved. So the customer was much happier. I was not very happy because I had to explain it, but at the end, the data modeling experience, the way to model data was different, because this was the correct solution in MDX. If you rely on multidimensional, this is the only solution you can use, because having aggregation, if you don't have a column containing this value, you are not going to be able to compute this expression at leaf level. This will never hit an aggregation, while this one will use aggregations. But since we don't use aggregation, this expression was much faster, and it is yet much faster. Then another scenario where things can be a problem is MDX script. I have seen a lot of code from MDX script from customers, and I have to say that the number of lines of MDX in a cube is a good indicator of how well the cube is designed. The higher the number of lines, then the lower level is for the cube. Because a very good cube doesn't need much MDX, just a few create measures and then some code to create new measures or to apply attributes or to do something strange. But if you start using scope to correct bugs, then of course you are not designing the correct cube. So the usage of MDX script should be for simple calculation and for some scopes, but I have seen too many times the entire business logic inside the MDX script. And if you are going to face such a scenario, then Tabular is not for you, because not having MDX script, you will not be able to move all this business logic inside Tabular. So, should you store business logic in MDX? No, really. There is no reason to store your business logic in MDX. Business logic should be in the ETL process, not in the code cube. If it is necessary, so you have no other way, then DAX is not your best option. MDX would be much better. But if you are doing business logic in MDX, then I think your best option will be to rearrange your cube, move all the business logic out of the cube, and then decide whether you prefer tabular or multidimensional, because the problem here is that MDX should not be used to do business logic. And finally, when it's time to ask yourself, should I port my solution? I already have a solution, it is working well, but it might be better in tabular. Yep, it might be better, but it means you will need to rewrite a lot of code. You will need to rearrange everything. You will need to recreate the database. You will need to follow a completely different data modeling technique. Is it really worth doing? I don't think so. There are not many scenarios where it is really useful to move one application from multidimensional to tabular. If it is already working, let it stay there and just focus on new applications. There you have the choice. You can decide to go tabular or to multidimensional, and you have time to make experience. There are scenarios where my actual solution is not performing well. We have problems, and this time a prototype in tabular might be a good idea, but don't expect it to solve all the problems of all your application, because sometimes you will still have problems. And porting doesn't mean run a wizard and look at the result. Porting means create a new project. There is no wizard that converts multidimensional to tabular. And even if I'm pretty sure that on the market there will appear some third-party tool that says, I will open your multidimensional project and convert it to tabular, then simply don't trust it. It cannot be done so easily. Or if it can be done, it's a wizard work. Not a wizard, a real wizard like Harry Potter. It's really a wizard of Microsoft Windows, so not a good job, not something you could trust. And finally, in tabular, there is another thing which is important. In multidimensional, the BI path, you have data model complexity and user requirements. As they grow, of course, everything is more complex. But if you are running with multidimensional, you have one tool to solve everything. You don't have any other options. And the only programming tool you can use to work with multidimensional is Visual Studio. So you need BI professionals in order to create anything you want in analysis services multidimensional. And this is good. I mean, we got a lot of money because there is multidimensional and we are the only ones who know how to make it work. But now, the sad reality is that there are really too many users and too few BI professionals. Or if you prefer, there are not enough BI professionals because BI demand is always increasing. In tabular, we have different scenarios because we have Power Pivot for Excel. We have used it for creating a simple solution. And this can solve simple problems with simple complexity, and this can be done by users. There is no need to ask to be a professional. Then we have Power Pivot for SharePoint, which is analysis services running in SharePoint, which already solves a lot of problems. It doesn't have security, it doesn't have partitions, it doesn't have some feature, but it's already powerful enough for, I think, I have no numbers, but probably 50% of the cubes which are already running can be executed in Power Pivot for SharePoint without too many problems. And then you have Tabular. If you want to do a very complex scenario, or you have a lot of data, of course, you need to go on server mode, and Tabular is your only option. When it comes to develop all this code, you can use Excel for Power Pivot for Excel and Power Pivot for SharePoint. Excel means you do not need to be a professional. Of course, I'm not expecting, as Microsoft is, to see all Excel users to immediately become the seasoned BI professional that will be able to solve all the cubes, but they will build something. And there will be probably new programmers and new people that learn to use Excel and learn to solve BI problems without knowing all the details of Tabular and all the complexity of DAX. If you need to do something really complex and really serious, at that point, analysis services is still there. But Visual Studio is very high. So they raise the bar in order to make it hard, to make it more difficult to have the need for Visual Studio. They can start doing BI very early. And they can start doing it without spending a lot of money. And then, at the end, they will spend a lot of money, but they will already have the feeling that they need to do something really complex. So, to go to some conclusion, Tabular is not really the new UDM. In UDM, they used one technology, and that technology was going to be used for all the solutions and all the problems. Now we have at least two technologies, and two technologies, one of which is in different flavors. Power Pivot for Excel, Power Pivot for SharePoint, and Analysis Services Tabular. So it's slightly different. Now they have opened a lot of capabilities, a lot of possibilities. DAX is easier. It's much easier to learn, much easier to use than MDX. So it's something that pretty anybody can do, just spend some time. So basically, if you are new on SaaS, don't spend on analysis services, then don't spend your time on MDX, go Tabular. Learn Tabular, learn DAX, learn the correct way, not the correct way, learn the easy way, because you will probably be able to solve most of your problems just by using Tabular. Then, if you need MDX, you can spend time learning MDX, or probably you will use a new version of Tabular, which will already have more power and will already be able to work better. Even because, keep in mind that Analysis Services Tabular is the new kid in town, not only for us, but for Microsoft too. So you can expect Tabular to have a lot of features in the future, while I don't honestly expect to see multidimensional to have a lot of features, because if they have to decide where to invest money, I think they will invest more money on Tabular than on multidimensional. Just think about the difference between SQL Server Analysis Services 2005 and Analysis Services 2012. After 7 years, we cannot say that there is a big difference. What you had 7 years ago, you have now, which is a way to say it is a mature technology. Mature is not dead, but it's near to the death. New on SaaS. So if you are new on analysis services, go Tabular. If you need to build a new project, consider Tabular as an option. And consider it trying to open your mind and forgetting about multidimensional. Right now, I'm working with a couple of customers in the USA, and I'm doing something that I considered craziness, which is I'm building a tabular cube directly on top of a relational data warehouse, an immune data warehouse. So I don't build the data mart. There is no reason to build the data mart. It's not that there is no reason. It's not necessary to build the data mart if you just go tabular, because we are speaking about relational modeling, not dimensional modeling. So even if I was used to have an immune data warehouse and then from them build a Kimball data mart and then from the data mart build the cube, Now I'm doing something that is absolutely contrary to my belief, which is remove the data mart and build the cube on top of the relational data warehouse. And I have to say it's working pretty well. I don't have many problems. All the formulas are pretty fine. And it's much easier, it's faster, and development is easier. So just experiment. We are here for that because SQL Server 2012 is a few months of life, and so we all need to experiment. Of course, you need to learn DAX. Don't think that you will learn it easily. Modeling techniques are different. So what next? Again, I think that I end most of my presentation with learn DAX, seriously learn it, just because I like it. So I want people to learn it. Learn different modeling techniques. Beware of the fact that all what you know about dimensional modeling is not something that you should forget, but you should take it aside and build new technique. Spend time to get acquainted, build a prototype. Don't even think about starting immediately with a customer. Build a prototype, play with it, take experience, try it, read blog posts, and do whatever is needed to learn, and then learn to think in DAX. Right now, we don't have one model to route them all. We have two models to route them all, but the idea is always the same. Probably in 7 years, we will meet again and say, BISM is dead, and now we have a new data model which will contain 3 different flavors, but which basically will mean we are going better, because now we are better than a couple of years ago where we had only UDM. I have no idea what the future is, but I think that we will see something new and something more interesting in 7 years, because we started from 2000 to 2005, then from 2005 to 2010, I think 2015, 17, we will probably see something new. But before then, DAX is probably your best option for a few years. That's all. If you don't have, or if you have any question, of course, I'm here to answer any question. Otherwise, if you don't have any question, and I think you are pretty tired at this point, because I spoke for a lot of time, just thank you for coming here. No question. Thank you very much.